Welcome to this tutorial on composites simulation. During this video, you will acquire knowledge about the simulation of composites on Simulia 3D Experience. For this tutorial, we will use this geometry, a winglet part. Download the file attached to this tutorial, and save it on your computer, in a directory of your choice. By the end of this tutorial, you will be able to log into 3D Experience and prepare the environment, set up a simulation, insert step, boundary conditions and load, define simulation outputs, and finally, perform a results analysis. Let's get started. First of all, you have to log into the 3D Experience platform. Open the 3D Experience login window, and put your ID and your password. Then, click on Login. Once you have logged in, click on the compass and filter on the apps to find the Composites design application. Launch it. Once the application is opened, click on the plus button at the top right and click on Import. Import the file named composite_simulation.3d.xml that you put in the directory of your choice, and as soon as the import is complete, press Ctrl+O to open the part, or right-click on the 3D part, and click on Open. Let's start a simulation. Click on the compass and run the mechanical scenario creation application. A new physics simulation will be created in a new tab. You will be prompted to select the simulation type. Then, from the Setup section of the action bar, choose Select Finite Element Model. Toggle on Preview the highlighted model. Review the previously defined surface mesh and solid mesh options. Choose Solid Mesh, and click OK. We will create some groups for use as supports of loads and restraints. Switch to Structural Model from the action bar. Note that the active context is the solid mesh that was previously associated with our scenario. Use the tree to show the solid from ISO thickness areas and hide other geometric features. Zoom in on the edge of the winglet which is close to the rosette. From the Group section of the action bar, choose Proximity Group. Change the name to Clamp, the entity type to Node, and the tolerance to 1 mm. Use the toolbar to select multiple faces efficiently using face propagation. Choose one face then propagate with a tolerance of 15 degrees to select all other faces on the edge. Click Update to ensure that there is a non-zero number of nodes contained in the group. Repeat the operation by creating another proximity group named Pressure with an entity type of element face for all faces which would be on the tool surface. Review the tree, noting that a new container has been added to solid mesh named groups. We need to define a step, boundary conditions, and loads. From the Setup section of the action bar, choose to check Finite Element Model to update the groups. Review clamp and pressure by selecting them in the tree. Switch back to Mechanical Scenario from the action bar. From the Procedures section of the action bar, choose Static Step. Accept the defaults by clicking OK. Then, from the Restraints section of the action bar, choose Clamp. Set the support as the proximity group named Clamp by selecting it from the tree. Click OK. Finally, from the Loads section of the action bar, choose Pressure. Set the support as the proximity group named Pressure by selecting it from the tree. Enter a magnitude for the pressure of 70,000 Newton by square meter and click OK. We also need to define the interesting outputs. For the study, we want plots for the stress-based failure criteria like Psi-Hill, Psi-Wu, and Hashin criteria. We also want a plot of strain. Expand structural analysis case.1 in the tree, followed by output requests. Some default output is requested when creating a given procedure. Double-click on output.1. Expand stresses and add TSHR. Also, add MSDRN and DMICRT. Similarly, add TSAIH and TSAIW, which are within failure measures. Change section points from default to all. Default will provide stress and strain output only at the top and bottom plies of each element. All will provide output stress and strain output for all plies of each element. Click OK. Furthermore, it is important to define some values in the Material Simulation dialog box. The simulation domain defines the mechanical properties of the material, anisotropic, elasticity, and failure criteria. In the specification tree, click on Material Simulation domain. The dialog box will appear. Tick the Hashin damage dialog box, and put the following values. Ensure that these boxes are checked: fail strain, fail stress, and elastic. Now it's time to run the simulation. From the Simulate section of the action bar, choose Model and Scenario Checks, and then choose Simulate. Accept the defaults by clicking OK. When the simulation completes, close simulation status by clicking Close. Let's analyze the results. From the Plot section of the action bar, choose Contour Plot and create a Stress Components plot. Also, visualize the hashing criteria failure plot with the 4 available templates. Furthermore, create an MSTRN contour plot to visualize the strain. To see the stress-based failure criteria, create Psi-Hill and Psi-Wu criteria contour plots. You can also create a layer thickness to visualize the thickness in all parts. Repeat the same actions ply per ply. Finally, it is interesting to create a ply stack plot. Select the Ply Stack Plot tool in the Plots section of the action bar to create a detailed rendering of a ply stack for a selected element in the model. In the Ply Stack Plot viewer, the thickness of each ply represents the actual relative thickness, the fiber directions are shown for each ply, and the shape of the ply stack plot matches the actual element shape when plotted in element orientation mode. Create a ply stack plot and visualize it, as well as the ABD matrix. This is the end of the tutorial. In this video, you learned how to log into 3D Experience and prepare the environment, set up a simulation, insert step, boundary conditions and load, define simulation outputs, and finally, perform a results analysis. Don't hesitate to watch this tutorial again, and reproduce all the steps by pausing the video.